Okay, in this example, we're going to look at a slightly more difficult angled projectile. In this case, we have a cannonball fired from one ship at a height of 5 meters above the sea level, let's say, with an initial velocity of 20 meters per second at an angle of 21 degrees above the horizontal. And we want to know, A, what's the maximum height the cannonball will reach during its flight, and then B, if it misses the intended ship and then lands in the sea 5 meters below where it started, so it basically at its initial height, what is its range? How far did it travel horizontally? So we see it's an angled projectile, so right off the bat we should be thinking, this is my velocity, this is my angle. Let me find my v naught y, my v naught x. So in this case, v naught x is going to be, this is 21 degrees, this is 20 meters per second. So I have 20 meters per second, the magnitude cosine of 21 degrees. V naught y is 20 meters per second sine 21 degrees. So if I do that arithmetic, I get 18.672 meters per second for my x, 7.167 meters per second for my y. Okay, now let's break it into our parts, x and y. X parts, y parts. Alright, let's try to get color-coded here. I haven't been doing a good job of that. We'll do x in green. What do we know about x? We know ax is 0. We know v naught x is 18.672 meters per second. We do not know delta x. Okay, for y, ay negative 9.8 meters per second squared. And v naught y is positive 7.167 meters per second. And I want to know delta y at the peak, top. Okay, so this is the first half of the problem. Well, what do I know? I know that Vy at the top is 0. So I can apply that. I do not know my time. And we do know that that would connect to the 2, but do I need the time? Well, it turns out I don't, right? If I want to know delta y, and I know the two velocities, initial and final, and a, I can go straight to equation number 3. Vy final is Vy initial squared 2ay delta y. So I subtract that over, divide by 2ay. Get delta y is my final velocity squared minus my initial squared over 2 times my acceleration. And if I calculate that out, I get delta y is 2.621 meters. Now, is that my answer? Is that my max height? Well, no, because that's just telling me my change in y. Right? I should just call that delta y. I should really call this the height. So if I'm asked a question about max height and I have an initial height, to get my final height, I need to take my initial height plus my delta y. So I have to take the 5 meters plus my change, and so I would get the final height max of 7.621 meters. So be careful if you're asked a problem like that. Make sure you include that initial height. Okay, so that one's not too bad. Second one gets a little more challenging. So let's say I miss the target and land 5 meters below. So my delta y is going to be 5 meters. What would my range be? And remember, range is asking for delta x. What's this distance? Okay, so now I'm looking at a new set of givens, because I'm looking at the whole entire flight, not just the half flight. So I would highly recommend setting up 2 tables. It helps you keep the information separate. Now, some of the information is the same, but not all of it is. The accelerations are the same. Oh, let me keep green with x. Meters per second. Delta x equals question mark. And AY is negative 9.8 meters per second squared. B initial y is the same, which is 7.167 meters per second. Now delta y in this case, I'm landing 5 meters below where I started, so I'm going to take my delta y as negative 5 meters. And what do I want to find here? I want to find delta x. I know the time connects the two, so if I look at delta x, if that's where I'm going to end up, delta x is v naught x times delta t, remember because a is 0. So I have v naught x, I need delta t, so I go back to my y, and I notice if I have a, v naught, and delta y, I can use equation 2. But in this case, it's a little more complicated because I don't know, my delta y is negative, it's not 0, so I'm going to have a quadratic. So if I go to the second equation, I can solve it, but I have a quadratic. So to set this up, let's do the calculator solve. I think that's the easiest way, and I think that's the way I'd like you to practice it. Now you could do the negative a, or negative b plus or minus square root of, I don't even remember, b squared minus 4ac over 2a, something like that. Hard, lots of algebra. Let's just get used to using the calculator. So I'm going to substitute in my values. And then this is a minus, it's 1/2 times minus 9.8, so it's always minus 4.9 meters per second squared times delta t squared. So I've got this on my TI app. Okay, you're going to do it on your TI calculators. Let's turn this off for a sec. See if I can get this zoomed in. Okay, all I've done here is I've plotted two functions. So the first one I put in, well, I don't want to add another one. Let's go back. I don't need a third one. Where do I see my first one? That's the problem with new things, okay? My first f of x is my left-hand side of the equation. So I plot -5, a line at -5, and then I plot my function of the right-hand side of my equation, which is the 7.167 delta t minus 4.9 delta t squared, and x is my delta t. And I want to see what value of delta t is it equal to -5. So I have two roots here, a negative root, and we can't have a negative time, so I got to look at my positive root. And what I did here, now you can do it on your 83. I don't have my 83 with me, or your 84. You just plot this as a y1 and y2, and then go find the intersect. So in this one, on the app, now if you want to get this app, it's kind of cool, TI Inspire. It's your TI for your iPad. I go to Analyze Graph, and for you it's like second calc. I'm going to find intersection, and it'll ask me for my lower limit. So I want to surround it with my lower and upper, and then it tells me the intersection. So in this case, my time where this function is equal to -5 is 1.9784 seconds. 1.9784 seconds. So on your calculator, it's the same thing. Plot -5 line, plot this, see where the intersection is using their second calc for the positive value of delta t. So here I've got this. Now I can solve for my delta x. Oh, and I noticed the light is off. I had to turn the light off so we could see the TI. Sorry about that. Let's go back here, turn the light back on. All right, V naught x, 18.672 meter per second. Delta t, 1.9784 seconds. Seconds will cancel. I'm left with meters. That's a good thing. And then delta x equals 39 or 36.933 meters. Now, one thing to consider with these problems, notice I didn't round off my time. If I'm using time to calculate distance, whatever values you calculate initially, you can store them in your calculator. Just use the full decimal value. You don't have to round to sig figs, because when you're doing the problem sets on Moodle, you want to make sure you're within 1% of the final answer. So if you round off your time to like 2.0 and use it to find the position or the range, you might get outside that error. So always just use the decimal form, at least 3, 4, 5 digits, or store it in your calculator, and that'll help. So this is the range from when it is shot to where it lands, and it's a little more complicated because we had to use the quadratic.